Laboratory work number 3. Calculation of structural and variation characteristics for statistical population. You can learn all the theoretical information in the protocol of this laboratory work, so let's begin. First of all, we have to calculate the model value for the sample A. In this case, function model is applied. So we have obtained the value, frequency of which is the highest, and median. So we can see both values coincide, but it's not a rule. They could not coincide in some cases. So let's continue. These formulas offers the sample B. And these formulas as well. Our next step is calculation of the mean of the dispersion, mean square deviation, and average linear deviation. So let's try mean square deviation. To calculate the mean square deviation, first of all, we have to know dispersion. And mean square deviation. Okay. And then we have to calculate the average linear deviation. But we have to do some operations. We have to know the sum of these differences in numerator. We have to determine this sum. To define it, we have to know the average values, and we have to calculate the difference between these values. And pay attention, this is module. The function abs is used to define the module. So we have already calculated average linear deviation according to this formula. We have determined the difference between x values and average x values in this set of our calculated data, and we have known modules of these values, and we divided this value on the number of our data. Function short, you have to know this function. Dispersion and mean square deviation we have already determined. And now we have to determine the variation coefficients. We have to know linear variation coefficient, square variation coefficient, and oscillation variation coefficient. This is determined as d by 100 divided by the average value. The d value, this is average linear deviation, so let's try. Linear variation, okay, and square variation coefficient. In this case, we use the sigma value, mean square deviation value. Okay.